Okay. Hopefully everybody can hear me okay. So, as we introduced a lot of different concepts in chapter 1, this is going to be the lecture for chapter 2, which mainly deals with population, overpopulation, and health. And so, as I promised you in the previous lecture, I'm not going to spend, 30 minutes like I did the last time introducing a lot of the concepts and discussing them. Some of them are pretty straightforward, but nonetheless, there are still some new concepts that we need to introduce, as well as some key terms that will be important. So I'm going to start sharing my screen. Hopefully, we can see that. And so this is not the beginning of the PowerPoint, right? So it's your responsibility to read through the PowerPoint entirely. And in addition to the readings, again, my lectures are just to kind of expand upon those readings and provide a little more clarity if something may be unclear. So, as you've read overpopulation and the definition about it, there's really an important way that social scientists in particular study populations. And in the US, that has to do with the census. So the census is the most important data source specifically for geographers, but other social scientists too, right? And it's every 10 years. So I'm sure you've all heard about the 2020 census coming up. If the census taker hasn't come into your house, I'm sure you've gotten notifications in the mail to fill that out. And there's important reasons for that, right? Because depending on how many people are in an area, even if they're undocumented, that depends on how much federal funding they receive, right? So in the current political and social climate, it might deter some people that are undocumented from answering the census. However, there's no legal repercussions from filling out the census, even if you're undocumented, because it's simply just a survey to know who lives in the area and how many people, right? And as well as some socioeconomic um, characteristics about them. When I say socioeconomic, it deals with specific variables such as income, age, right, gender, race, educational attainment, if you own or rent your house, if you own a vehicle, right? Personal characteristics like that. The census is controversial in other countries, mainly because some people choose not to participate, namely, as I just mentioned, undocumented groups that may be fearful of filling out the census for other legal purposes, even though that's not true. Homeless people tend to not fill out the census, so there's never really a good representative count on the number of homeless in any country. And then citizens of other countries who maybe who do not have the proper documentation, but maybe they're contemporary workers in the U.S. Right. Another thing is sampling. So statistics are used um, to get a more accurate count. So the census is designed to survey everybody, but sometimes that doesn't happen, right? And then so statistical techniques are applied to try to get a representative sample, but sometimes those error rates in the statistics are very high and unreliable. So right now we're on slide 9, and we're talking about the distribution of the world population, right? And so again, I'm just trying to elaborate on some of those key concepts and the key terms. Again, please be reading the chapters so that you're familiar with these. If you've never seen, I'm sure some of you have seen a cartogram, but it depicts the size of a country on a map according to the population rather than the actual size of the country itself. And so this is what this looks like, right? We know that China and India have the most people in the world. And so on a cartogram, we expect those two countries to be the biggest. It's a pretty cool representation just of population, but I wanted to make you aware of it in case you've ever come across this or have never encountered it before. It's one of the ways geographers display population data. So I'm not going to go through key issue 1 too much because it's just dealing with where populations are distributed. And again, we know, right, that distribution is what? We remember that from the example of looking at the US population by counties in the previous lecture map. And I said, remember, if we looked at it in 2000, 2010, 2020, and we'd expect those shaded green areas to change, right? That's distribution. Well, that's the same thing holds true, right, on a global scale. And so key issue 1 is really just discussing where the different population concentrations are or densities, right, are on Earth. And we know that most of the population um, overall, globally, lives in Asia. And almost 66% of all people live within 300 miles of water. Now, Why? Right? Let's use spatial thinking. It might make sense to say, well, that's the coast, and there's transportation and there's ports, and yeah, that's great for a physical location, right? But how about the social implications? How about the environmental implications, right? The political, right? And if we really look at all examples from around the world, like capital cities, most capital cities are on the coast and within 300 miles of water. There are a few exceptions, but most major cities in the U.S. and across the world, right, are near bodies of water. So I want to cover types of densities. So before we introduce what density was, right? And density is just a frequency of how much a distribution occurs, right? And we use population as the example, but there's different types of densities. So we have population density, which is literally just the number of people that occupy a space, right? But there's arithmetic density, which is the total number of people divided by how big the land area is, right? So for example, the US is huge. So the US approximately has 77 persons per square mile nationwide, right? But if we looked at New York City, right, there'd be over 1,000 persons per square mile because it's so dense, right? And again, density is another concept that we need to be familiar with. So make sure that you are good on the concepts introduced in Chapter 1 before you start progressing through more readings. So this is population density per square kilometer, right? And again, I just said, if we look at over here at the US, we can see that the New York City area, or the megalopolis, and a megalopolis is categorized as major cities that are close to each other. So on the northeast coast, you have, Washington, D.C., Baltimore, Philadelphia, New York, Boston, right? And it kind of goes up that corridor from Virginia all the way up into New England. However, right, there's other countries that have much higher population densities than the US. And because it's not surprising that we just said most of the population on Earth is concentrated in Asia, so we would also expect Asia to have the highest population density, right? And that is reflected here. But there's other types of densities. There's physiological densities, which is just arable land. And arable land means how much of that land is farmable, right? How much is able to be used for agriculture. So the US, in the US context, right, there's 404 persons per square mile of arable land, which is farmable land, right? That's different from nationwide just saying the population density is 77 people per square mile. When we get to arable land, more that's usable, right, we see more people that concentrate around agricultural land. Then it's not surprising that Egypt almost has a little over 9,000 people per square mile, right? And why? And where do you think they might be located, right? If you have thought about the Nile River, which is, one of Egypt's only main sources of water, then you are correct, because Egypt has to feed the entire country based on just this small piece of arable land around the Nile River. Then there's agricultural density, which is a little different, right? So two places can have the same physiological densities, but their agricultural densities can be different. And that is the ratio of farmers to the amount of farm, right? So don't get confused with arable land. Arable land is physiological density. When you think of agriculture, just automatically think of farmers, right? So if I asked you, what's the agricultural density of the US? You can say 4 people per square mile. Or another way to think about that is 4 farmers per farms, right, in the US. So the last thing I want to spend time on here is something we call the demographic transition model. And it's a way that social scientists and geographers in particular have organized development in the world based on population characteristics. So what does that mean? So geographers measure it in 3 different ways and using 3 different criteria. So there's crude birth rate, which is just the amount of births per 1,000 people. So 20 means there's 20 births per 1,000 people, right? Crude death rate, the same exact thing as births, but for deaths. And then we have the rate of natural increase, which is the percent by which the population grows in a year. And we can calculate that by the crude birth rate minus the crude death rate. Now, if you have a country with a high birth rate and a high death rate, what's the percent of natural increase? If you said low, right? You're correct, because while there are a lot of people being born, there's also a lot of people dying. And so the rate of actual increase overall, the actual people living, right, into older years in their life is low because the crude death rate is so high. And then we have the more on the rate of natural increase, but we also have something called total fertility rate, which is the average amount of children a woman will have throughout their life. So globally, it's around 3. In Africa, it's about 6. And in the US, it's actually less than 1. And so while you go through the text, it's important to think about why you see these differences across the globe for total fertility rates, right? Education and educational opportunity for women is huge, right? The more women are in the workforce, the more women are able to have opportunities to go to school, the less children they tend to have. So there's types of growth, right? Based on the crude birth rate, the fertility rates, the death rates, and the actual increase. So we have moderate growth, which is just, regular, consistent, normal growth, no spikes in any kind of graph or any kind of extreme trends. We have low growth, which is zero population growth, where the death rate is increasing, but the birth rate is decreasing. So again, the crude birth rate increases, and the crude death rate increases. The number of people dying increases, but the crude birth rate declines. So in this kind of zero population growth, what kind of countries are characteristics of that? Mostly those in Northern Europe, right? Like Germany, Italy. A lot of those countries have a much older population because younger people are not having children. So most of Europe and the US have not fully entered that zero low growth yet, because there's still more people being born than dying, and people living into their adult lives thanks to the advancements of modern medicine. And so we have still a moderate growth in the US. So I mentioned to you, the demographic transition model, which is a process of change, right? And we monitor these crude birth rates and crude death rates and the rate of natural increase by country. And so in stage 1, and don't worry, I'm going to help, there's going to be a graphic here that's going to help you visualize all of these stages and stuff. In stage 1, the crude birth rate is extremely high, but the crude death rate is extremely high. So as I said before, if you have a lot of people born and a lot of people dying, then the rate of natural increase right here, very low INR, happens because not a lot of people are living long lives. Are there any countries currently in this stage? No, there are not, which is great, right? There might be some remote groups globally that experience that, but countries overall, no. So why? Well, the Industrial Revolution, right, made improvements in manufacturing goods and delivering them, so more people had access to food, right? And also wealth, right? Because what do machines do? They allow people to save on labor, right? And so stage 2 didn't hit Africa, Asia, and Latin America until 1950. Right, so the developed world, as social scientists call it, are the wealthier nations, right? The UK, Japan, the US, what else, right? You can think of some. But the major factors that pushed stage 1 into stage 2 was medicine, obviously, right? Because without medicine, without the polio vaccines, the death rate would be extremely high. So what does stage 2 look like? Still a high birth rate, still a lot of people being born, but less people are dying, right? So when you have a ton of people being born and the rapid decline of people dying, people are living longer lives, which means the rate of natural increase is very fast, very big. So what countries are in this stage, right? I'll let you guys think about that. Think about, as you see the characteristics for each stage, think about what countries might be in them, right? Stage 3, declining birth. Not as many people being born, still people being born, right? Moderately declining death rate. So the death rate is slightly increasing, but there's still more people being born than dying. So because of that, the rate of natural increase is moderate, right? In stage 3, people have fewer children. And we talked about some of the opportunities, right? Education being one of them, why women have less children. So what countries do you think are in stage 3? But if we think about it spatially, right? I've been really emphasizing the spatial components. What factors lead a country into stage 3? If you guys want to write about that as a reflection, that would be awesome. But it's not just one factor, right? It's not just medicine. It's not just economics. It's not just political, right? All of these factors have to combine in order for places to advance. And then lastly, stage 4, very low birth rate, low or slightly increasing death rate. So more people are dying now than being born in stage 4, which means a 0 or negative rate of natural increase. The population's either just staying the same or it's dying off. What kind of countries are in stage 4? And what kind of social factors contribute to that? So this is what a model of this demographic transition looks like. And so we can ignore the right side here, stage 5, because it's a hypothetical stage. And why I say it's hypothetical is because it hasn't really been accepted by experts. So the experts kind of go with stages 1 through 4. And again here, right, rate, we have the crude birth rate, and the black line is the death rate below it. And we see both of those are high in stage 1. And so the total population, barely increasing, right? Because so many people are dying, so many people are being born. But stage 2, birth rate's still high. Now, modern medicine, right, declines that death rate significantly. And so what happens when more people are being born than dying? The rate of natural increase goes up. But when we get into stage 3, as we see the birth rate start to decline, still more people being born, though, in stage 3 than dying, and the death rate starts to drop off, the rate of natural increase starts, it's still going up moderately, but it's not as such a big spike as in 2. And then when we see the total population, right, this red line, that means that the crude birth rate and the crude death rate are both very low, and there's no replenishing population. So the total overall population is old here, right? This high line is, you can think about this total population line as typically people over 50 years old. And then down here, it gives you those same characteristics that I was talking about before, which are also illustrated on my previous slides. The birth rate's high, the death rate's high, right, for stage 1. So you can go through these and study the characteristics. I just wanted to elaborate on some of the stages and their characteristics in the demographic transition model, why the demographic transition model is used, and why it's important to monitor population growth. This I had as an in-class exercise, so if you guys want to check that out, you're more than welcome to. Let's see what other concepts we have here. So after we've covered the demographic transition model, you should be getting to key issue number 3 in the text. And it introduces sex ratio, which is the concept that the number of males per 100 females in the population. So that's how it's measured. So in North America and Europe and some parts of Latin America, right, there's slightly more males than females. But in China and India, which are the 2 largest countries with populations, right, on Earth, the rate is 112 males to 100 females. That's not random. Why? Let's think about some of the social factors that contribute to that, right? So again, when we think about the spatial components, we can apply this to any kind of problem or issue or phenomena that we see to help us give a better overall comprehensive understanding of what's going on, right? Also, though, not irrelevant of China and India's social factors, access to ultrasound machines, medical equipment, and cultural preferences for a boy, right? In those countries, males are preferred, right? If you're having a kid, people want it to be a boy because that's the social culture there. While that is changing, right, it's still the dominant view. So the gray line here is culture, right? As we just talked about the social factors for why there's more males in India and China than the rest of the world. And so the UN kind of steps in and says, hey, if you don't know what the UN is, it's the United Nations, which is just think about it as a league of nations, right, that work collectively to try to solve global issues. They recommend more effective approaches to address the root cause of sex selection. So the UN's kind of stepping in and saying, hey, I know culture matters here, but we need to address this in a sensitive way. And so how do you go about addressing social issues, right? If they say that if they are going to have a small number of children, right, they want males, which is what I told you before. So how do you address social gender inequality, right? Not just, measuring it through the pay gap or the income gap that we see, males and females and other genders being paid, right? But how do you change that way of thinking, right? And one of the ways is to include all these spatial components when you are providing a solution, right? Because you could be the best, social explainer there is. You know all the connections and why someone's making a decision and what that person's thinking, but without the economics, without the power in place that reinforces maybe that person's way of thinking, the information that person's receiving, there's no way we can provide comprehensive solutions to anything, right? And so lastly, what I want to introduce here is called a population pyramid. So it takes the demographic transition model now and visualizes it using a bar graph. Pretty cool, right? So each bar that you're going to see on the graph is a 5-year age group, right? And so if we look at the population pyramid of Israel, and hopefully this will be more clear to you when I upload this PowerPoint, you can download it yourselves. I'm not sure how good the screen sharing is, but Israel 2016. All right, males are on the left in blue, females are on the right. What do you see there? What's the age structure like, right? Here's the age. So what can we say? Can we say that Israel has a younger population, an older population? What else can we say about examining these things? How many people are maybe retired? How many people are in the workforce? How many people are still, in school, like secondary school to high school? And if we look at Niger in 2010, you have population in millions on the bottom. And again, these 5-year age gaps, right? Each bar is 5 years of age difference. What can we say about Niger? Well, they have a large working population, but even a large young population, which means that the older population, there's less old people, right? And so when we see these kind of differences in the bars, and if it's usually higher at the top than it is at the bottom, that means a country has a higher dependency ratio, which means that a country has a lot of older people that rely on the working class to support them, right? And the larger the dependency ratio, the greater the financial burden it is to people, or working people, right, to support those who don't. So, for example, the dependency ratio, right, is 47% in Europe and 85% in sub-Saharan Africa. So either under the age of 15 or over the age of 65, you're thrown into being dependent. Infant mortality rates, it's similar, right, to the crude death rate, except it's the annual deaths of infants under the age of 1 compared to the total live births, right? So if you die during infancy, which is, till 1 year old, then that's what contributes to the infant mortality rate. If you pass infancy, then it's not calculated in an infant mortality rate. But even if they survive infancy, children in developing nations in particular are at risk, even though there have been these advancements in medicine and access, to cities with resources. It's still disproportionately unequal. And the elderly ratio, I kind of elaborated on that with the differences in the bar structure, right? If you see the bars that are longer at the top, that usually means, you have to read, of course, the age groups to make sure, right? I might trick you with that on an exam, but just look at the bar graphs. And so if there's longer at the top, that means there's a lot of older people. And if it's longer at the bottom, wider at the bottom, that usually means they have a younger working population. Now, don't get confused, because if you see longer at the top, skinny in the middle, and longer at the bottom, what does that mean? That means that there are a large, large dependency ratio, excuse me. Why is it a large dependency ratio? Because if these bars here were longer at the top, that means that typically people over the age of 65 would comprise of a significant part of the population, whereas if it got skinnier in here, people during their working years, there wouldn't be that many, and then 15 and below would still be wide. So you'd have wide at the top, skinny, and then wide again. That would be a very high dependency ratio. Now, depending on the length of the graphs, that's how many people, total are in that category. So infancy, right, 0 years old, 1.6 million for males in Niger compared to slightly less than 1.6. So the length of the bar is also going to tell you the total size of that age group's population. So consider all of these if I ask you a question, right, to fill in a demographic transition model, or if I give you an example, you need to be able to justify to me why it's, what stage it's in, right, why it's in that stage, what does the dependency ratio look like, is it a high or low, and tell me why, right? The rest of these, you guys can you can go through them because I just introduced the concepts of the demographic transition model, and this is more diseases that are associated with each stage. So getting into the health aspect, right? Stage 1 has usually famine, right? Stage 2 is a receding pandemic, right? Ironic right now because of COVID, but these are more kind of infectious diseases. Stage 3, like if the US was in stage 3 and you could justify to me why you think that, then stage 3 would be categorized by degenerative diseases, right? Not infectious diseases where people are having bacterial infections and dying, and not usually viral, but things like cardiovascular diseases and forms of cancer. And then again, stage 4, if you go back to the chart that visualizes the demographic transition model, you'll see that Germany, for example, is listed in stage 4, and they would be accompanied with delayed degenerative diseases, right? Things like dementia and other hard to prevent diseases. So the rest of the key issue 4, why might the population increase in the future, right? This is on your own. This is your own reading. I can test you on any of this though. So just know that, okay? I'm trying to help you out and just make sure you have everything covered, because I'm only introducing the things that I think conceptually are important for you to reach the learning outcomes of this course. Okay, and then lastly, if you want to take a look down here, possible solutions to, get other countries out of stage 2, right, and possibly stage 3. And then when we talked about some of the social reasons, right, for why the turtle fertility rate, and recall what that is again, right? The number of children that a woman will have in her lifetime, and then why that would change. Check out the last slide on education and healthcare. Okay, I hope this was useful for you. I hope this helped illustrate some of those concepts that might have been a little challenging. And again, if anything is unclear in this, please feel free to email me.